Hello and welcome back. This week we're going to be discussing multiple regression. There's many different aspects of multiple regression that we'll be discussing. The first is the mechanics of it, and hopefully you'll see that doing multiple regression really isn't much different from the regression that we've been doing so far when we just have a single predictor variable. Now that you know how to build those models, adding other parameters is easy. You just add the parameter and then make sure that you add the appropriate priors, and you should be all set. So we're actually not going to spend that much time on the mechanics. I'm going to include the code for all of the models that are in this video, and so you can look at the code yourself, but I'm not going to spend a lot of time on going through the code of the multiple regression models, because I think what's actually more important in multiple regression is really understanding what you're doing and what it means and how not to dig yourself into a hole. So multiple regression, I think, is probably the most misunderstood, maybe other than p-values, one of the most misunderstood and most frequently misused tools in statistics. I'd say almost 90% of the papers that you read conducting multiple regression have some errors in their interpretation. And so, although multiple regression is very powerful and allows you to do many things that we want to do, it also can really hurt. Like, it can also really lead you to incorrect conclusions. And so really one of the main things that we'll spend time on is trying to teach you some skills and some methods that you can use to make sure that you use multiple regression effectively, regardless of if you use Bayesian approaches or frequentist approaches or anything. The strategies that you'll learn will be useful regardless of that. Okay, let's get started. Okay, so again, now that you know how to build basic models, you actually also know how to build multiple regression models. You just add more predictor variables. So we'll just briefly go through some of this. So here's an example of a model with multiple predictor variables. So in the past, we dealt with estimating beta 0 and beta 1 with our one metric predictor variable. So if you want to add more, you just add more. So you have a different coefficient for each of your new predictor variables. And so your likelihood doesn't change much, right? You're just adding the coefficient times the whatever value you have for that metric variable. And then you just have to make sure that you include adding priors for each of those new coefficients that you add. So you can add as many coefficients as you want to your model. And so normally we do them additively like this, but there's no rule that says you have to do it this way. If you think that some of your predictor variables have different sorts of relationships with the predicted variable, you just include that into the equation. But most often it's going to be additive here. So this is how you build a multiple regression when you have metric predictor variables. Similarly, if you have categorical or nominal variables, it's the same idea. You just add a new coefficient for each of the levels within each categorical variable. And so here with our first model, we had J levels in our first categorical variable, and so K levels in the second, L levels in the third, and so on. Often when you have multiple, so when we had just one categorical predictor variable, we didn't include beta 0 there. Instead, we just estimated the value of being in each level within this variable. But when you have multiple categorical variables, I find, you don't have to, but I find it's helpful to have beta 0 in here, and then what this will represent, it's the average value across all levels, across all of your predictor variables. And then each coefficient here is the degree to which being in each of these levels bumps you above or below this average value. So when you have multiple categorical variables, I find it's helpful to include beta 0. And so again, here's how your likelihood would look, where it's no different. We're just adding more terms to it. And again, adding, making sure that we include priors for each of the new coefficients that we're estimating. And so again, there'll be different levels, different numbers of levels for each of these, so you just need to make sure that you account for that. And you're not limited to just one or the other. We can have mixed models, right? Most of our models are going to be a mixture of metric predictor variables and categorical predictor variables. And so building these is no different than what we've done, right? So here's a mixture. We have our beta 0. Here we have a categorical predictor variable. Here we have a metric predictor variable. And here we have a categorical predictor variable. So again, nothing's really different, right? We're just, as long as you code the categorical variables appropriately, and oops, looks like I did this one incorrectly with that bracket there. Anyway, and then code your metric ones appropriately and do your priors appropriately, right? So for categorical variables, you just need to include a prior for each level, whereas obviously there's just one prior for the metric coefficients. So you can kind of mix and match these however you see fit for your data and just build the appropriate model. So this is why we spent so much time going slow through building basic models, because then once you understand that pretty well, getting more complicated models, all you're doing is just adding more variables, and it's not too complicated. One thing I do recommend when you're doing multiple regression is build your models slowly, especially if your models are getting complicated. Everyone makes coding mistakes, and so it's easier to troubleshoot the simpler your model is. And so normally if I'm building complicated models, I'll just build it one parameter at a time. So I'll make it a single, I'll have one predictor variable, run it just to make sure that it runs, that there's no errors. Then add the second predictor variable, run it and make sure that it runs, or debug it. Then add the third one, and so on. So just build it incrementally, and that will make your life easier. It might seem like it will slow you down, but it's going to make finding bugs in your code much easier if you just build them slowly, one parameter at a time. Okay, so that's kind of the mechanics of building multiple regression, and I know we didn't go through them in much detail, but hopefully you get the idea. So why should we use multiple regression? So multiple regression is extremely powerful and useful. One of the main benefits of using multiple regression is it can allow us to identify spurious correlations. So these are correlations between two variables that don't really exist, right? So they look like they're there, but they're not really there. So maybe when we look at a pairwise comparison of two of our parameters, it might look like there's a strong relationship between them, but maybe in reality there isn't one. And so if we just did a pairwise analysis or a single regression, we'd erroneously think that there was a relationship between some predictor variable and our predicted variable, when in reality there isn't one. And so multiple regression allows us to test for these sorts of issues, so to identify spurious correlations so that we don't come to incorrect conclusions about the effect of a predictor variable on a predicted variable. Another very useful aspect of multiple regression is essentially the opposite of what we just talked about, is it can identify masked relationships. So for example, in this case, when we compare a predictor variable to the predicted variable, it might look like there's no relationship. But this could be due to some other effects from a third variable that we're not accounting for. And then when we do account for that third variable, we see that there actually is a relationship between our predictor variable and our predicted variable. So if we just did a simple regression, we'd say, oh, there's no relationship between our predictor variable and the predicted variable, where in reality, there is one. And so multiple regression allows us to do both of these things. And that makes them extremely, extremely powerful. So what it does is it allows us to estimate the effects of one predictor variable on the predicted variable while also accounting for the effects of other variables. And that's the key for multiple regression. There's a lot of problems with multiple regression as well. They're actually they're huge black holes of misunderstanding. And again, you could almost pick any paper at random that uses multiple regression and you'll see issues with it. They're often used and interpreted incorrectly. And so what we're going to do is spend a great deal of time going over how to use them responsibly. All right, so I think we'll stop this video here before we go through some examples.